So what we decided to do today is we're using a product over here called MorpheusX. It allows you to take multiple observation streams from multiple vantage points, but they're all spatiotemporally synchronized. The other thing going on here is as the sensor observations are being done, they're being archived temporally. So if I were to do it, we could just stop any one of these things and scrub it and go back for like an instant replay, or we can just do an after action report of like, hey, what happened in that place? So every time we do an exercise, it's all stored out temporally. So everything here we'll just be able to replay at any time that we want. An error occurred while rendering.
Okay.
I suspect that's going to happen. And we have a bunch of different sensors. You just saw a few of our people with the, I don't know what you call that.
So
Body cams.
Oh well, yeah, but they're wearing some fancy thing that you put your body cam on, and they're walking around, and you can actually see all their kind of pose information as they're going through. And we are sitting here at a nadir view in Cesium. If you're not familiar with Cesium.js, right, it's a full 4D. Those are the folks that drove the OGC 3D tile specification. We were going to get fancy and actually fly this morning and put it out in 3D tiles, but we decided not to get fancy because we already had a couple things break. But you can see, right, it's not just showing them in 2D what direction they're pointing, but the actual calculated field of view of those Android devices that they have on their chests. We also could have gotten fancy and actually broadcast the video there, but instead you're, where are they? Here you go. You're seeing each of the video there, and with all of the telemetry data and all the pose information for every single frame of all the video that's going on. What that lets you do, right, is you can actually kind of do spatiotemporal coincidence of, you know, who's looking at that from that side, et cetera, and it's all calculated. So you could run that through an AI/ML, whatever process you want to go do. So that's going on with all of our folks there. We also have, the target is the terminus of the last laser rangefinder pulse. And I don't know who's in charge of that, but somebody's going to be pulsing it. You do that for different things. Not only, you know, once it's connected to the Android OSH instance, right, it inherits kind of the location information. So you're not just getting, you know, that this is 100, you know, that the pulse is 102 feet away. You can actually precisely geoposition the pulse, the thing that you're pulsing, and you can use that for tipping and queuing of other sensors. Here is just to show that, right, a sensor observation stream isn't just the geospatial part. Sometimes you actually want to peel pieces out of it that show people relevant information. In this case, it's kind of the pan and tilt angle. In this case, it's the distance of the true pulse laser rangefinder. These are actually kind of lame, I hate to say it, charts. But you can just pull things out where you want to show the altitude of the drone as it's flying. And that's easy to calculate and pull out of the telemetry, but you need it in a different window. And you want to know that that's tied to this other window, which is the actual drone footage, tied to the other window, which actually shows the drone flying in 3D, tied to another window that shows it in 2D, right? And there's a lot of different use cases for why you want to have multiple spatiotemporal vantage points and non-spatiotemporal vantage points all synchronized in time up on your COP, right? Got a bunch of other stuff. This is actually a totally, wait a minute.
Yeah.
That's WebTAK?
Yes.
Okay, so this is actually a totally different top, and we do that. This is, if anybody from the special operations community in the US, well, I guess it's used globally now. The team awareness kit is what started in the special operations community. It's now used by police and fire and all sorts of different folks around the United States and the world. And there's ATAK, the Android team awareness kit. Which we could show. Nick probably has it on one of his phones, unless we've given all of our phones to the people out there.
Might be an occasional there.
Right, so I could also have the mobile version of what's going on here. This is WebTAK, where it's just in a browser. The limitation of WebTAK is that it is one core map and the ability with OSH integration to pop what we call them pop-ups, but they obscure the map itself, right? So they're not coordinated pop-outs like you have in MorpheusX. But this is to just show that we have the exact same sensor feeds that are being viewed here and on this laptop and on his Android phone if he popped it up. You could have N client applications that are all listening to the same connected system API simultaneously, and everybody's using the task appropriate client, right? The client that's appropriate to their task. So it could be their ATAK that they just drop down from their chest and they see everything, or it could be Mission Command or some management interface that sees it on 3 big screens, or it could be somebody sitting in the back of a tactical vehicle that just has a, or an emergency vehicle or a non-emergency vehicle, whatever, that just has a laptop and all the screen they really have for themselves is WebTAK. We had some, where'd the drone?
It's not started yet, so we'll do that again.
Well, it was up a minute ago.
No, that was the robot.
Oh. No, we had the drone with the ADS video. All right. So anyways, one of the things you saw was a drone flying around. Those are actually simulated data off of testbed 8.
View.
Oh, the other drone. Yeah. You wanna show
How many drones do we have?
There's a real one and a simulated.
Right. So I'll show you the simulated one. So this is the opportunity. You can mix simulated data with real-time data because this is the data that was provided to us during testbed 18 of a synthetic ISR. So it's a synthetic flight of a synthetic, I guess that's a,
MQ9 or?
that's MQ1. MQ9? Oh, it's like one. All right, MQ9. And that's synthetic ISR of synthetic vehicles moving on the synthesized, right, full motion video that's on there. And that was done specifically to say, okay, here are the vehicles, here's the time that they're moving through a bunch of different, I think it was radiological sensors was the testbed 18 scenario. Anyways, we just reused that. These are actually real-time ADS-B feeds coming off of the PyAware. The PyAware that's actually halfway across town because it's talking over the web, publishing a connected systems feed off of a Raspberry Pi. And we are doing that with a simulated feed that's operating off of a cloud instance, I don't know, wherever Google's got their cloud. And then you can also see a chart that's being generated here off of the sensor field of view. Right, that's the horizontal field of view calculation.
Right.
So basically how big the swath is. Is that right? But that can be anything, right? We can be pulling some other information out of the feed and showing it just for giggles or because it actually matters, right? I don't know. What am I missing, guys?
Talk about the PTZ. Yes.
So are you actually gonna task it? So we have a pan tilt zoom camera. Where is it?
It's right behind
You can't see it. Well, you can see it. Try to tell them. There's a pan tilt zoom camera. There's a pan tilt zoom camera. It's on that little tripod there. The whole point there is it's got a pretty good field of view of the botanical. Yeah, there you go. So it's got a field of view of the botanical garden, and it can be tasked through geolocation. Now, a lot of pan tilt zoom cameras are dumb as it relates to they don't know where they are, right? They don't have a GPS, they don't have a magnetic compass, so they don't know their directionality, and they do have kind of accelerometers to kind of know, but unless it's paired with the other, you can't generate your position of it. So what?
I'm doing PTZ testing now. Just
Okay, well, there you go. So this is actually using a screen tasker. So we're not using the laser rangefinder, we're just saying, let's task this. Kind of like if you had a remote control car, you're using kind of the little thumb connections, we're just doing it off the screen. It's speaking connected systems over to a remote internet connected sensor there to make it view. But we also can equally task it using the laser rangefinder. So we can do that. And when you point at something, it'll slew the camera over there because it's taking precise geopositioning off of the laser rangefinder that it's actually inheriting off of the Android that it's connected to via Bluetooth with the OpenSensorHub that's on it that's speaking connected system saying, here's what I just geolocated being passed over as a task to a pan tilt zoom camera that knows where it is because it's been grounded, all right? Connected systems. Anybody get the joke yet? Ah, snap.
Don't say that. They were not supposed to know this.
No, they know this. We also have our UGV out there. I don't know where.
It's over by Kaylin.
Okay. All right, is she taking a picture of the UGV? So if you missed Nick's presentation, I could have Nick come up here and give another. That's the UGV?
Yeah. I can set it in motion from here.
What, using connected systems from the...
the connected systems industry, we're gonna go back, we don't have a user interface to test it,
right.
but we can test it through OpenSensorHub.
Right.
And then the data stream will be fed through connected systems back.
So traditionally, when you buy this UGV, you get like a little joystick, right? And I can move around just like you do an RC car. But it's robot operating system there with all of the autonomy package with a global map and then kind of the ability to locally optimize by getting where you want it to go. Let's give it a destination and it will automatically avoid all of the obstacles and get there and replan dynamically. So herky-jerky, like there's a thing in front of me, turn this way, reposition, you know, stuff like that. So the work that Nick did, because I hate to say it, like the UGV community aren't all geo people. They just like, hey, this will run around inside. Isn't that cool? So we actually had to do, buy the additional GPS on Amazon for 25 bucks, jam it in, download the ROS package, and that all was inherited by the larger ROS OSH driver that makes it available through the connected system. So the types of things, I don't know what the hell's going on right now. Got stuck in the pine needles. But you can actually, the same way you can use the laser rangefinder to give it a task, you can just drop a GPS into it and it would find its way there using the global map, probably getting stuck in the pine needles. Oh, hey. Which one? Oh, there you go.
So yeah, the middle one's definitely so in that middle screen we have the top right is the PTZ camera behind the screen, right? And then the user down the bottom right where it says Android LRF, that's our guy with the laser rangefinder. So he just shot a target, which is that white building in the camera screen, the top left. So the PTZ moved its location to point to that building.
So both getting observation streams in of various different kinds, along with all of the information, not just kind of its location, but the actual, the field of view, all of its position information, everything's dynamically calculated to get its field of view off of its pose. And the sensor capabilities, right? It knows what is that sensor capable of doing, what is the sensor geometry and things like that. What am I missing, guys? We've got tracks of, in this case, this is configured to show kind of the historic tracks as the individual moves. You can see what their path had been and how they doubled back with some track decay, right? I'm sure some other stuff's going on. What am I missing? What?
Could you possibly add a drone?
You could possibly add a drone. Where's it? All right, somebody's flying a drone now.
They're about to. They're waiting to be cubed.
Go for it.
Cue the drone.
He says it's good. Now, you have no idea how hard this is, because not only do you have to have an FAA certified drone pilot, then you have to actually get flight rights from the local Army airfield. And the only reason we were able to pull this off. Where's Casey? Is he out
Might be
there?
down there.
It was because Casey down there, and we found out about this morning, yesterday morning, because of Micah. Where's Micah? Thank you, Micah. So Micah heard me say,
Casey made this happen.
yeah. So it's one thing to have sensor integration, it's another thing to legally be able to execute it. So if the batteries aren't dead and it flies, then that'll be one more thing. So right now, that particular drone, because we had a 3D solo where the battery pack died, that was integrated via Mavlink. So you can think of like an architecture of standards. There are other standards out there for like flying drones, Mavlink, right? But how do I coordinate a UGV that is using ROS and a UAS that's using Mavlink? Well, you use connected systems and a piece of software kind of like OpenSensorHub or somebody else's implementation of connected systems. So there.
One is here.
Which one?
This guy here.
Well, he's there. Where's his video? That one? All right,
Yeah.
and that's over there. Right, so you're actually taking off a DJI commercial drone. It's GPS and all of its pose information and its telemetry, right? And that's I assume that's an H.264.
Yeah.
Is it with MISB encoding or just the vanilla? So OpenSensorHub supports a variety of things. If this was a DoD drone, it would be H.264 with MISB encoding, if any of y'all have hung around here long enough to know what that is. But a lot of the commercial ones don't have that, right? Sometimes you'll see it get maybe not this one, but herky-jerky is because a lot of the commercial drones don't do time well. So they don't encode the telemetry along with their video in a synchronized way. So the positional information will be herky-jerky. That's not an issue of the standards. It's an issue of kind of the quality of the integration on the drone itself. Not uncommon. I will say over the past 15 years or so, they've gotten, in general, better. I think consumers have demanded that just because they want to look super cool when their drone is following them as they go down snow skiing on a mountain. They want like cool video, and you need smooth stuff.
Are we supposed to be waving at the drum now?
Yeah, wave the drone. It has a loitering munition. It'll be here in a minute. It's sad when you can laugh at that. But,
Could we possibly see the drone using the Stanfield Zoom camera?
I don't know. Can we? Oh, we can. Where is it? Which one is it? So I've got two cameras.
Top left from here.
Top left.
And drone video here.
So where's the tracking of the drone with the pencil zoom camera?
Right here.
That one? I don't see
Or if you
it.
go to the middle screen, it's
That's the DJI Mav link on WebTAK.
Right up here.
oh, there it is.
It keeps popping in there a little bit. I think
We lost it.
it's at the bottom. It fell off the bottom of the screen.
Oh, there you go. Now then, that's an issue of like precision geopositioning is only as good as like the quality of the GPS that's being broadcast. If there's any temporal latencies on the spatial, right, you lose synchronization. So it's an issue of scale, right? So you just zoomed out and you're going to be able to follow it better. If you zoom up and there's any lack of synchronization on the spatial temporal, then you lose something, right? That's kind of a data fusion targeting issue that's perennial. What if I not? There's a lot of stuff in here,
I'm
guys.
gonna send the robot rolling, so the bottom right hand is playing the screen.
All right.
Alright, so she's moving slow, bottom right.
This is the video
On the
here.
grass, yeah, let me slow
Right.
them up.
And that's actually, that angle, is that off the drone? Off the
Yeah, that's the drone.
off the UGV or the drone?
The UAV.
Okay, that's the pitch angle and the roll angle. Again, it could be anything that's non-spatial that you want to have on the chart.
And you have the battery on.
The video is not refreshing for the drone.
Nah, something's gonna happen. I guess that's what's happening today.
Chris, just to clarify, at no time are you actually driving the drone, the airborne, the UAV by the hub, it's just collecting telemetry.
Currently,
Yeah, right now, yeah.
The pilot is driving it.
The pilot's driving that.
Yeah.
It is being tracked autonomously
Yeah.
by the PTZ. Right.
But it's not getting tasked.
Correct. No, the other one would have. This one isn't because our batteries died on that 3D solo, and Ian brought this one from home.
Yeah, so
Yesterday.
not enough time to test tasking on this one.
Yeah.
But it can be done.
But we can be.
Yeah. So it would just be part of.
Easy to do.
Right. It's a control stream.
Yeah.
And a control stream goes over MavLink. And so that's the sort of stuff we've done, right? So in a control stream, you would control a UAS differently from how you control a PTZ, from how you do a UGV, from how you task a satellite. But the way the OGC sensor web architecture and the connected system architecture works is when you, at least in OpenSensorHub, when you write that Java code to make OpenSensorHub create the service, it is a self-describing sensor, right? SensorML self-describes what the sensor, am capable of doing.
Yeah.
And so over real time, it's being updated. So then it would know where it is, and you'd say, hey, can you go do
that
this?
conversation.
And it's that conversation.
Yeah.
And that's as sophisticated as kind of the feasibility software is that's between you and the drone. Like, like I think somebody said, like you wouldn't just steer a satellite. I think that was Matt saying that, right? You'd go to a piece of feasibility planning software that, you've kind of entrusted with doing capacity management on that. And a big topic, I think, with Theodore's presentation, right? They're building that kind of management software for UXS for, how do I have a conversation with it and tell it where I want it to go based on mission profile. So, anything I'm missing? So I feel like that's it. Like I'm gonna stop talking. I think they'll just keep doing stuff. I think you guys should feel free to come and talk to our folks, ask any random questions. I'm sure I misrepresented something horribly, and I'll go to tech jail after this. But I appreciate you guys taking the time and coming learning about Connected Systems API and kind of what the potential is, where it's going, what we're trying to do. And if you have any like comments on the specification, on what you think it should be doing that you don't see it doing, please get involved in the Connected Systems specification process. It's all on GitHub. Like, you can literally just get in there, and if you're that nerdy, you can go do that. And I mean nerd in a nice way. So we'd love to have you all involved. So thank you very much.